Hello. So in this video, I'm going to look at a particular question involving a linear relationship, linear function, and more specifically, I'm going to show how we can use the slope-intercept form of the equation of the line. That's the y equals mx plus b format. How we can use that particular equation to answer the following question. So going to share a different screen here. There we go. So this is the question. We want to write an equation in slope-intercept form for a line that passes through the point -7, 12, and that is perpendicular to a line that has an equation -3x plus 5y equals 18. So just point out the -3x plus 5y equals 18 is what's the general form of the equation, sometimes referred to as the standard form. And for any sort of linear equation and however many variables you have, basically this is what you're looking at. You've shown something times the first variable plus something times the second variable plus something times the third variable. If you wanted, you could have infinitely many variables here. In theory, well, I guess you wouldn't really go to infinite if you're dealing with the usual cases, and then that's equal to some constant. So in this case, we have just the two variables, x and y, and -3 times the first variable plus 5 times the second variable equals the constant. The equation that we're going to come up with is going to be in slope-intercept form, but if you have slope-intercept form, you can easily change it into standard form by just multiplying and moving terms around. Little basic algebra, some of the stuff you learn the first few days of algebra. So anyway, this equation we have for a line, and we're going to create another line which is perpendicular to it, and we're going to find the equation for that. Now there are, of course, infinite number of different lines which are perpendicular to any particular line. But in this case, we have some more information. We have the information that the line is not only perpendicular, not only at a right angle to -3x plus 5y equals 18, but also the line we're looking for is passing through the point -7, 12. Okay, I'll go back to that screen I had up here before, which was the GeoGebra. So this is a freeware program. You can download it to lots of devices, or you can actually run it. You don't need to download it. You can just use a browser and go to the GeoGebra website and work there. So this is GeoGebra Classic 5 to create. So this line is actually the line which had the equation for -3x plus 5y equals 18. I put the information down here in a little input box and created this. But again, this isn't the line we're looking for. We're looking for a line that's perpendicular to this and just happens to pass through the point, what was it again, -7, 12. So I'm going to bring up the whiteboard and do a little algebra here. So there's our whiteboard. This will make it a little bit bigger there. Okay, so, well, if we're going to use the slope-intercept form of the equation, what we need are two things, of course, the slope and the intercept. Remember that the intercept in this case is the y-intercept. So we need those two things. Well, let's take the equation that we already have. So line, red's an okay color, but I prefer black for mathematical work. Let's erase that. Okay. So we have the equation -3x plus 5y equals 18. We can use the slope-intercept equation to find the slope of this. Just need to rearrange it so it's solved for y. So to solve for y, to get y by itself, really just 2 basic algebra steps. 5y equals, we'll add 3x to both sides, so we get 3x plus 18. And then to finish getting it in slope-intercept form, divide through by 5. That gives us y equals 3 divided by 5, 3/5, times x, so the slope is 3/5, plus 18 divided by 5, 18/5. I'll leave it in this format, but you could change 3/5 into 0.6 and 18/5 into, what is that, like 3.6, must be 3.6. Yeah. But this form works just fine for us. The only thing I'm saying is it doesn't matter whether you think of the slope as being 3/5 or whether you think of it as the number 0.6, it's still the slope. But if you want to think of the slope in terms of the rate of change of the function, then the fraction works pretty well, because what this is telling us is that every time we take 5 steps to the right on our line, we're going up 3 units. And we can see that if we go back to the GeoGebra window here. If you look here at the x-intercept, which is -6, notice it's not the y-intercept. So the y-intercept we just found, which was positive 18/5. That's actually here. We can find, if we were to zoom in here, we can find 18/5. Like I said, 3.6, I don't know if you can see that, but 3.6 right here. Anyway, I'm going to zoom back out here to see the larger picture. And we can check the slope, see that everything's right here. So -6 here is the x-intercept. If I go 5 units to the right, 1, 2, 3, 4, 5, 6 to 6 equals -1, and then go up 1, 2, 3 units for the slope of, again, 3/5, positive 3/5. And sure enough, seems to be passing through that point there at -1, comma 3. Okay, we'll leave GeoGebra for the moment and go back to our whiteboard. Again. So here we are with the whiteboard. And we're looking for a line perpendicular to this line, y equals 3/5 x plus 18/5. Now, any line perpendicular to another line is going to have a slope that is the opposite of the reciprocal of the slope of the line it's perpendicular to. That's a lot of words, and so mathematicians, we try to find statements which are concise and precise, where there is no question of the meaning and it doesn't require a whole lot of writing. I sometimes think that math is just the creation of really lazy people. They don't want to do too much work. So the nice, concise, precise mathematical way of saying that is if 2 lines are perpendicular, there is a special case where you've got horizontal and vertical where technically this doesn't really work. But in every other possible case of 2 lines being perpendicular, that whole mouthful about their slopes being opposite in sign and reciprocals in terms of their absolute values, which I think is what I said before. Now what that comes down to is if you multiply the 2 things together, well, if they're opposite in sign, then it's one's positive, one's negative. You multiply them together, you get a negative. And if their absolute values are reciprocals, then that means that when you multiply 2 reciprocals together, you get 1. And so what all that means is we have the opposite of 1, -1. Now, in this particular case, you can look at the slope of the line we have already graphed here, and that had a slope of 3/5. Well, the opposite would be negative, and the reciprocal is 5/3, so you don't need to go through all this stuff. But if you wanted to, we could go ahead and say, okay, we're looking for a slope m(1). And if we take that and multiply it times 3/5, it has to be equal to -1. So this is a sort of formalism that we often have in mathematics and mathematically based sciences. And so you solve this equation for m sub 1. Oh, I lost my negative there. Let's fix that. And what that comes down to is, well, how do you solve for m sub 1? Well, it's m sub 1 times something, so we divide. Dividing by a fraction is equivalent to multiplying by its reciprocal. So either way, you could write it in terms of division. If you write it in terms of division, it's helpful to remind us that 1 divided by 3/5 gives us the same result as if we multiply by the reciprocal of 3/5, which is 5/3. So -1 times 5/3. And any way you look at it, we end up at the same result, -5/3. Okay, so just to go back over what we've covered here so far, what we found is the lines, the slope of the line we're interested in. We want to find the equation slope-intercept form for the line that's perpendicular to the line -3x plus 5y equals 18, and also passes through that point -7, 12. Well, we now know the slope, so we're kind of halfway there. So let's go to a different screen here. So remember that slope, -5/3. So what we just found, I'll just call it m now because we know that it's really the only slope we care about at the moment. So I'll just call it m. Well, maybe I'll stick with m sub 1. So the slope was -5/3. For the remainder of this exercise, we've got a couple of choices. One possibility is to use what's called the point slope equation. It's a useful tool. You should be aware of it. But although it's useful, on the other hand, it's also kind of unnecessary because really everything you can do with point slope, you can also do with slope intercept, and slope intercept is slightly more efficient in the fact that it gives us that specific information. Really, at the higher level of thinking about this stuff, they're essentially the same equation. But anyway, the point slope form says that if you take the difference of the y value that well, the generic y value, y standing for any possible y that works here, minus a particular y value, usually called y sub 1, that's equal to m times the generic x value minus a particular x value, x sub 1. And you could actually manipulate that equation by dividing both sides by x minus x sub 1, and if you did that, you'd have y minus y sub 1 divided by x minus x sub 1 is equal to m, which, if you think about it, is really just the slope equation. The difference of the y values divided by the difference of the x values is equal to the slope. Okay, so you can use that. I'm not going to use that because my theory of the whole business is if you can get by with just one equation, and that one equation is really useful, just make that your general tool. But you should know that the point slope version of this equation, you should know that it exists anyway and be able to use it if you need to or want to. Anyway, going back to slope intercept, y equals mx plus b. This is quite specific because it gives us the y-intercept along with the slope. We know the slope, we don't know the y-intercept. That's not really a problem because all you need is 1 point, plug that in for x and y, and we can figure out the y-intercept. But if you were to go back to the point slope, we could just plug directly in what we already know because we know that the y value is 12 and the x value is -7 for the point that the line has to pass through. And so let me just make a little notation over here to remind us that -7, 12 Again, not the y-intercept. Sometimes people get confused about this and think, you say y-intercept, but they think y-coordinates. So they look at that 12 there and think, oh, there's the y-intercept. No, 12 is the y-coordinate at this particular point, but this point is not the y-intercept. This is just some other point on the graph. So how do you use y equals mx plus b? Well, we know m. So we know that y is equal to m, negative 5/3, times x, plus the so far unknown b value. And so we've got 3 different letters here, 2 variables and an unknown constant. But we can figure out the unknown constant because we know that the point negative 7 comma 12 is a solution to this equation. It's part of the solution set. So if I plug in x equals negative 7 and plug in y equals 12, the b has to be the particular number that makes that equation true. So we have y is 12 equals negative 5/3 times x has to be negative 7 plus b. Well, let me see if I got all this right here. So negative 7, 12, xy. Okay, yeah. Looks good, I think. So negative times positive is, negative times negative rather is positive. So we're going to be looking at a positive number there. Now, you've got a couple of choices here. So sometimes what I'll do in a situation like this, if I don't want to mess with the fractions temporarily, just want to point this out. You can multiply both sides of this equation by 3, so you just don't need to worry about the fractions so much. Nice little trick. So which will give us, so if you multiply by 3, the 12 becomes 36. The 3 in the denominator goes away, so we're looking at positive 35. And then we also have to multiply the b by 3, so give us 3b. Which looks like, if you subtract 35 from both sides of that equation, looks like 3b would be 1. And if 3b is 1, looks like b is 1/3. Let's go ahead and keep the fractions and look at the math that way. So if we keep the fractions, we've got 12 is equal to negative 5/3 times 7, so it would be 35/3 plus b. So 12 minus 35/3 is equal to b. 12 has to be changed to 36/3 for purposes of fraction subtraction. And again, we get what I said before, 1/3. Okay, so now we have all of the information, but I don't have any room on my screen to write down our final answer. So I'll go to the next screen and we can write that down, and we'll go back to the GeoGebra program and see if this makes sense. So new screen. So using, again, our generic y equals mx plus b, which again is the only tool you really need to carry this out. Well, we know all this stuff. Y equals, the slope was figured out earlier. It's negative, no, it's positive, it's negative 5/3, negative 5/3. Yeah, I wrote it down wrong here somewhere. Plus 1/3. Now you can check this by plugging that point negative 7 comma 12 back in here, and basically just some mental math tells us that's the right answer. Going back over the steps we just took. But we can also go back and let's take a look at the GeoGebra again and see how that works here. So what I'm going to do is enter my new equation in here, and we can look at it and see if we can convince ourselves that it has all the properties it's supposed to have. So if I go down here into the input area, I'm going to put in y equals, we got -5/3. Keep in mind that whenever you're putting a fraction in something like this, you want to use parentheses around the fraction so there's no confusion. So -5 divided by 3, and then we have x, and then plus. I probably don't need to put the 1/3 in parentheses, but just to be consistent with what I said before, I'll do that. So 1 divided by 3, and you probably noticed that as I was typing, it was drawing this other line here. Now, they certainly look to be perpendicular. I should point out that you can't necessarily tell by looking whether they're perpendicular or not, because if perpendicular, of course, means that this angle where the two lines meet is kind of special, that all 4 of the angles that are created by the two lines are the same size. They're the same measure. That's really the defining feature of what a right angle is, what makes a right angle right, the fact that it does that. And at a glance, they seem to be, but suppose that the angles are not actually all 90 degrees. Suppose that 2 of them are 91 degrees and 2 of them are 89 degrees. Not likely you're going to be able to tell the difference between that and the situation where they're all 90 degrees. So we can't trust our senses. That's what math teaches. One of the things math teaches us is to trust your brain, trust logic, trust reason. Don't trust what your eyes are telling you, or your nose, or whatever. Okay, so let's see. But in terms of perpendicular, certainly looks to be right. Well, the other thing we know about our line is that its y-intercept was 1/3. And looking at the picture here, that seems to be pretty close to 1/3, but we can zoom in and get a closer look. The decimal expansion of 1/3 is 0.3 forever. So we can zoom in forever trying to figure out whether it's exactly right or not. So here's 0.3 and there's 0.35. So somewhere between those, it looks like it's at about 0.33 and a little bit more, and it should be a little bit more than 0.33. And if you've got nothing better to do for a weekend, you could just spend your time zooming in here and getting a deeper understanding to the visualization of exactly what the number 1/3 is. 0.3, 3, 3, 3, and so on. Anyway, I'm satisfied. It looks to me like the line we're looking at is passing pretty close to 1/3. If you trust the computer program. I don't trust computer programs, but if they're in agreement with what the algebra was telling me, then I'll assume that everything's looking good here. So we'll leave it at that, and that's how you can write an equation for a line perpendicular to another line passing through a particular point. The only other thing I'll mention is that you could do something very similar for a line parallel to another line. The difference there, of course, is that in the case of parallel lines, they have the same slope instead of this whole negative reciprocal business. Anyway, I'm going to end the video right there, and thank you for watching.